Good morning. Myself, Ashakila Devi, Assistant Professor in Romani College of Engineering and Technology. Today, we are going to discuss the subject CS 8602 Compiler Design. In Compiler Design, Unit 3 is Intermediate Code Generation. In this, we are going to discuss about the syntax tree today. The outcome is, on successful completion of this module, the student should be able to illustrate the concept of syntax tree. Next, we are going to discuss about the syntax trees. Syntax tree is a variant of the parse tree. In a syntax tree, the interior nodes are the operators and the leaf nodes are operands. So the syntax tree is usually used when we are representing a program in a tree structure. Okay, so syntax tree is a tree structure. Here the interior nodes represents the operators and the leaf nodes represents the operands. And next we are going to see how we can construct the syntax tree. So first we are going to construct the syntax tree for this following arithmetic expression. So what is the first step is we have to convert the given arithmetic expression into a postfix expression. So this is a given arithmetic expression a into b the whole star into c minus d plus within bracket e by f star a plus b. So what we have to do first is we have to take this b outside so that take this plus outside so that it is become ab plus, and then take this minus outside so that it becomes cd minus. So now this become ab plus star cd minus. Then here take this slash outside so that it become ef slash, and then take this plus outside so that this become ab plus. Okay, so now we have this star operator, take it outside the bracket. So this become EF slash AB plus and star. So next what we are going to do is we are going to consider this one AB plus star CD minus. Take the star operator outside so that this become AB plus CD minus then star. Then in between that we have the operator plus, take it outside. So this become AB plus CD minus star EF slash AB plus star and plus. Okay. So this is a way how we can convert the arithmetic expression into an postfix expression. So next we are going to discuss the step 2, that is we are going to draw the syntax tree. The steps involved are start pushing the symbol of the postfix expression into the stack one by one. If it is an operand means push it inside the stack. If it is an operator means push the operator inside the stack and pop the operator along with two symbols. And then perform the operation by using that two operands, and then the resultant should be pushed back to the stack. So we have to continue this similar operation to draw the syntax tree simultaneously. So see what you have to do is, what is your expression? Your expression is AB plus CD minus into EF slash AB plus star plus. So first we have to put A, B, then plus. When you are taking plus, you have to add this A and B, right? So A plus B. So push the result back into the stack. So A plus B, then push C and D, then minus. When you encounter the operator, you have to perform the operation between C and D. So C minus D is calculated. The result is pushed inside the stack. So it becomes AB plus, then CD minus. Then again, we are having an operator which is star. So you have to perform operation in between these two, A plus B and C minus D. That is, you have to perform A plus B into C minus D. Then push the result back to the stack. Then after that, we have encountered the operand E and F. Then when you are encountered the operator slash, perform the operation in between E and F, that is perform E by F, and store the result back to the stack. Then after that, we'll get A and B, then the plus operator. So perform plus operation in between A and B. So that is A plus B, push the result back inside the stack. That is, it becomes A plus B. Then we are getting the operator star. So you have to perform star operation between the two operands, A plus B and E by F. So the result is E by F into A plus B. Then after that, we have encountered the plus operation that you have to perform between the two operands, which is a plus b into c minus d plus e by f into a plus b. Okay, this is a final answer. By using these steps, you have to draw the syntax tree. Okay, so how we can draw the syntax tree is first start it from here. First take a, b and plus. So draw a, b and plus. Then C, D and minus. So C, D and minus you have to draw. Then after that, perform multiplication operation between AB plus and CD minus. So the result of AB plus and CD minus is multiplied. After that, what is the operation? E and F is divided. Okay, so E divided by F. Then after the next operation is AB plus. So A plus B you have to draw. Then after that, we are getting the operator, that is the multiplication operator, that is we are going to perform multiplication between a plus b and e minus e divided by f. So the e divided by f and the a plus b result is multiplied. And finally, we have the plus operator which is used to add the two values of this result, that is a plus b into c minus d and then e by f into a plus b. These two values are added. Okay, so finally you have to add the plus operation as the root node. So this is how we can draw the syntax tree. Next, we are going to discuss the major differences between the parse tree and the syntax tree. And the parse tree is a graphical representation of the replacement process in the derivation. And the syntax tree is a compact form of the parse tree. So it is similar to the parse tree, but it's a compact version. And in parse tree, the interior nodes represents the grammar rule and the leaf nodes represents the terminal. But in the syntax tree, the interior nodes represent the operators and the leaf node represents the operands. And about parse tree, the parse tree provides every characteristic information from the real syntax. But the syntax tree does not provide the characteristic information for the real syntax. It just gives you the operator and the operand values, not the real syntactic values. And the parse trees are comparatively less dense than the syntax tree, but the syntax trees are comparatively it's more dense than the parse tree. Okay, so this is a basic difference between the syntax tree as well as the parse tree. And next we are going to discuss some tutorial problems in that. So consider the tutorial problem, that is E derives E plus T slash T, T derives T into F slash F derives within bracket E slash ID. Generate the syntax tree for the following string ID plus ID into ID. Okay, so this is the output of the syntax tree. So ID into ID is drawn first, then the result is added with ID. The next question is draw the syntax tree for the expression A is equal to B into minus C plus B into minus C. First, you have to perform B into inner A minus of C, then again B into minor A minus of C. The result is added. Then finally that is assigned to the variable A. And the gate question is, in the context of the abstract syntax tree AST, the control flow graph CFG, which one of the following is true? In both AST and CFG, let node N2 be the successor of the node N1. In the input program, the code corresponding to N2 is present after the code corresponding to N1. And the next option is, for any input program, neither AST nor CFG will contain a cycle. And the third option is, the maximum number of successors of a node in an AST and a CFG depends on the input program. And the final option is, each node in AST and CFG corresponds to at most one statement in the input program. The answer is option C, which is the maximum number of successors of a node in an AST and a CFG depends on the input program. Thank you.